So hello everyone, this is another of our videos where we will be showcasing concrete demoing examples that we will be showing for helping interested people get to know how to use our programming model and demonstrating some important properties. It will be organized in the form of a code walk to allow you to get quickly to the part of the code from where you can then further inspect and learn about these things, and we will be also providing appropriate documentation which should help you really understand and get started with using our code. So this scenario that we'll be presenting today is basically motivating scenario is when a user posts a question to our platform about restaurants with specific eating options in the vicinity. The question is then processed by the platform application representing our example and returned to the user. The processing collective is hybrid as it involves software services, Google with Yelp, and these are queried for the restaurants, but we also have the human peers which are queried via email in accordance with their personal delivery and privacy policies. The orchestration or the composition of the plan is software managed in this case, which means that the workflow is predetermined and there is no need for explicit negotiation between the peers. The workflow prescribes how the queries are dispatched and how the replies are aggregated. And now we will dig in exactly into the code. So what you can see here is our repository, and you can go to this link when it becomes open source, or you can actually also pull the code on your own. In this case, we are on our demo branch, and from this point on, a colleague of mine, Svetoslav, will take over and guide you through the actual code parts.
So for starting the scenario, we have to go to the scenario 1 module and to the scenario 1 executable file. In here we see the setup of the platform with starting the MongoDB and our local Mongo peer manager, which can be substituted by the peer manager from Trento.
Yes. So basically the whole point is that as was mentioned in the previous video, for the demoing purposes we have our local peer store which does not implement all the advanced privacy policies, but it does implement the same API. So this means that we can easily switch to using the one implemented by our partner at this project, the University of Trento, instead of it. But in this way we have our self-contained examples that you can run and play around with and allow you to explore the features only of the programming model independently of other components.
We are also setting up the SmartCom service, which is used to communicate with the different peers. And we are populating our database with some peers, which in a real life scenario would have been users that register to the application. In our case, we have one software peer, which is our Google peer, and 3 human peers. Afterwards, we are starting our application, and this can be done by simply running this main file. Now, after startup of the platform, of the scenario, we can simply write an email to the platform. This is smartcom.ssp@gmail.com with the subject RQI, which stands for Restaurant Question and Answer. And we can query, for example, for Japanese.
With the Japanese with and then just yep.
We are querying for Japanese in Vienna, in the 4th district of Vienna.
So basically, just to so now Svetoslav is playing the role of the user who is using the platform and asking the question. Of course, this being the demo, this is just a specific subject. Of course, this can be in the same way implemented using some specific user application, which would shoot to our application and our platform through the REST API. In this case, we just do it via an email to a specific predetermined email address.
Now, after after our platform receives the email, it will process it and it will inform the human peers about the new request which just happened. We have here, because of this account is also entered as an expert, we have here another one who got the email. Let's answer from here. We are answering with a restaurant. And let's also answer from this human peer who also received the notification.
Yes, so in reality those will be people who are registered for taking part in the application, possibly later on for some for some reward, some kind of incentive, or just if this were a much more advanced or complex task, also to kind of be able to get different solutions from the platform in exchange. But for the demonstration purposes, we are just now playing the roles of two human experts, which are replying to the asked question.
Exactly. Now, after replying, and sometime after all the replies are processed by the SmartCom platform, there will arrive a answer to our initial request. We are again in the role of the requesting user, and in this answer we can see the answer from our software peer, the Google peer, with a link we can click on. You can see there are the restaurants in the stated area with for example, Matcha Komache at second place, and we can also see the answers from our human peers, which are stating the same thing, basically.
Obviously, the point here was not to demonstrate that the logic or the expertise behind and the aggregating of the answers is advanced, but rather just to demonstrate the full end-to-end but basic functionality of the platform, allowing you to actually, in a very short and very concise way, leverage our platform to get some answers back to you, relying on both software and services. Of course, complex algorithms which would allow actually determining the best possible answer from aggregating the answers from human and machine peers would be possible, but this is not the purpose of this demo.
Now, behind the scene, we have a simple task runner which defines which library handlers are needed to perform this task we wanted to perform. In this case, we have specific handlers for provisioning, composition, negotiation, and execution, which are provided by the library. This task flow definition is then passed on as to a CBT. It's transformed to a CBT, and this is started. From this point on, we are saying that we want to wait 3 minutes at most for a result from our experts.
Yes, just as I mentioned before, the CBT runs in a separate thread, so we can do whatever we want in the parallel, and when needed we can block, in this case with the get, the timed out get method to actually fetch the result.
And after this method times out or is answered, we will send the response to our initial requester and end this task run. In the execution handler, maybe for another interesting point, we can see the actual execution of the desired task with sending the message, the question to the experts. This includes also the Google peer, and waiting for enough responses to satisfy a given quality of service before returning the result.
So I just go briefly back up to sending the message. So here the messages actually are sent by using our SmartCom component. Our SmartCom component offers a very simple interface to the actual developer, in this case to the programming framework library developer, or in this case execution handler developer, and this is simply to send a message, and message are built pretty understandably in a very nice and comprehensive syntax. Of course you would have to kind of check the documentation of SmartCom to see exactly what is the meaning of each of the specific methods, what are the types, specific types and subtypes of messages, and how they decide or determine the way the messages are routed, delivered, and also how specific peer preferences can influence whether the message will be delivered, at what time, and through which communication channel. In this case, once again I repeat, we always chose the simplest default options just to demonstrate the end-to-end connectivity and the basic functionality.